You know, when you look up at the night sky, it's really easy to feel a sense of absolute permanence, isn't it? I mean, for millennia, humanity has charted the stars, completely relying on their steady, unwavering light. But what if I told you that stability is actually just an illusion? In this explainer, we are going to look at real, documented cases of stars simply vanishing from the sky. And I want to be clear right up front. This isn't science fiction. We're not doing wild speculation here. We are strictly looking at hard data from modern astronomy. We're going to trace a path starting from mysteries that we've neatly solved right to the terrifying edge of the completely unknown.
There's a quote that perfectly sets the stage for our journey today. We assume the sky is permanent. The universe doesn't care what we assume. That is really the thematic backbone of this whole explainer. The cosmic catalog is not a static painting. It's a dynamic, violently shifting environment where things can, and absolutely do, just disappear.
Case 1. ASSN N24FW, the 1 in a million eclipse.
Okay, let's dive into this first suspect. We're looking at a star sitting about 3,000 light-years away from Earth. For over a decade of continuous monitoring, it was perfectly, boringly stable. And then, suddenly, it wasn't. Between late 2024 and early 2025, this completely stable star dropped 97% in brightness. It faded for 8 full months. To put that into perspective, imagine a bright street lamp suddenly dimming down to the light of a single birthday candle. Astronomers were totally baffled. Was the star dying? Was it collapsing?
Well, fortunately, the data provided a really neat scientific resolution. The Ohio State University team realized the star's color hadn't actually changed. That's a huge clue, because it meant the star itself wasn't evolving or dying. Something was just blocking our view. They discovered a massive disk of carbon and water ice dust that was 1.3 astronomical units across. That is larger than the entire distance from the Earth to the Sun. And the trigger for all this? A hidden, fainter companion star orbiting nearby, stirring up that massive dust cloud and causing a literal 1 in a million eclipse. So for Case 1, the status is firmly solved.
Case 2. Betelgeuse, the Great Dimming of 2019.
This brings us to a much more famous example. This is the massive red supergiant making up the bright right shoulder of the constellation Orion. In late 2019, Betelgeuse began to drastically fade, causing a massive wave of panic and excitement that the star was about to explode into a supernova. And this brilliantly illustrates what had everybody so worked up. As you can see from its light curve, Betelgeuse's brightness literally plummeted to historic lows during 2019 and 2020. Telescopes even captured images showing the southern hemisphere of the star looking distinctly dark. But it didn't explode. It eventually brightened right back up. So what actually happened? If we compare our first two cases side by side, we see a really fascinating pattern. While our first case was blocked by an external disk, Betelgeuse experienced a gigantic surface mass ejection. It essentially blew off a massive piece of its own outer atmosphere, which then cooled into a thick dust veil that temporarily blocked its light. The actual mechanics are a bit different, but this dust obscuration mechanism is a highly reliable explanation in astronomy. But as it turns out, Betelgeuse had one more secret hiding in the dark.
In July 2025, using the Gemini North Telescope, astronomers finally discovered why Betelgeuse behaves so strangely. It actually has a hidden companion star. It was affectionately nicknamed Betel Buddy, but formally proposed as Siwarha, and it's orbiting close by. This companion basically acts like a giant snowplow, constantly churning up the gas and dust around the supergiant. This discovery effectively solves a century-old mystery about Betelgeuse's long-term dimming cycles. So the big takeaway here is this: hidden companions in cosmic dust are the great illusionists of the universe.
But right here is where we need to pivot, because if you're starting to think that every missing star is just hiding behind a thick cloud of dust, we need to shatter that comfort zone. This is happening far more than anyone expected. We are moving away from isolated, neatly solved incidents and stepping into a systemic cosmic phenomenon.
Enter the astronomical detectives. The Vasco project was specifically created to hunt for these cosmic ghosts. The way they do this is fascinating. They take historical photographic plates from the 1950s, like old images from the Palomar Observatory, and they meticulously compare them to modern, highly precise digital sky maps. They are looking for points of light that were clearly undeniably there 70 years ago, but are completely gone today. And they haven't just found 1 or 2 weird glitches. They have found hundreds, literally hundreds of unexplained, vanishing stars. Even after completely ruling out variable stars, moving asteroids, and weird data artifacts, there are hundreds of stars that have simply vanished without a trace.
Case 3. The Kinman Dwarf, the star that vanished without a trace.
Now, what's really staggering about this next slide is the sheer incomprehensible scale of the object we're talking about. Located 75 million light-years away, this wasn't just some standard, everyday star. It was a luminous blue variable. It's shown about 2.5 million times brighter than our Sun. Stars of this type are absolute monsters. They are highly unstable and prone to incredibly violent giant outbursts.
And that is exactly what makes this disappearance so terrifying from a scientific standpoint. Astronomers regularly observed this massive star between 2001 and 2011, but when they pointed the European Southern Observatory's Very Large Telescope at it between 2016 and 2019, it was gone. A star of this immense mass ending its life should trigger a brilliant, unmistakable supernova explosion. It should have blazed with the light of a billion suns. But it didn't. There was no explosion. It just switched off. Status? Unsolved.
We are forced to look at two competing hypotheses here, and we really have to be honest about the limits of our current knowledge. Option 1 is extreme dust obscuration. Basically, the star experienced a massive outburst that expelled so much material it transformed into a dimmer star which is now heavily hidden by its own dust. Option 2 is a failed supernova. This is a theoretical scenario where a massive star's core collapses directly into a black hole, instantly swallowing the star from the inside out before an explosion can even occur. If that's true, it would be the first direct observation of a monster star dying this way. But right now, it remains completely unconfirmed.
And now we reach the absolute edge of what we know, a completely unexplained cold case. Case 4, the Palomar Mystery, July 19, 1952.
Let's move through this and see how this builds because the timeline here is genuinely chilling. July 19, 1952, 8:52 Universal Time. A routine photographic plate captures 3 distinct, bright, star-like objects in the constellation Cygnus. Just 50 minutes later, a follow-up image is taken of the exact same patch of sky. The 3 lights are completely gone. More than 70 years have passed. They have never been seen again.
The speed of light imposes very strict physical limits on what can happen in the universe. For 3 independent stars to simultaneously flare up and die out in less than 50 minutes, it completely defies our understanding of stellar physics. Unlike our earlier cases, dust clouds just do not move that fast. Failed supernovas do not happen in perfectly synchronized triplets. Right now, modern physics simply has no answer for this.
And it is not an isolated incident. The Vasco project found another archival case from 1950 where 9 objects vanished in just a 30-minute window. We have no supernovas to blame. We have no fast-moving dust clouds to explain the suddenness. There is no neat scientific resolution here, just cold, empty space where light used to be. We build our understanding of the cosmos on the assumption that the sky is a reliable, predictable canvas. But cases like the Kinman Dwarf and the 1952 Palomar Mystery, they prove that the universe is far stranger and far more volatile than our models can currently explain. The stars feel eternal, but the universe doesn't care what we feel.